about section 1.6. I pulled up the syllabus here, so we're going to start class 7 today. We'll finish it on Tuesday, and then class 8 is a quiz. Okay, so Tuesday we have our first quiz. It's in 2 parts. The first part will be a group quiz, and the second part will be an individual quiz. They're going to be quizzing similar concepts and asking similar questions, but it's not going to be like the same quiz but with different numbers. Okay? Same concepts, same types of questions, but not exactly the same quiz. So the group part will really help you sort of get everything settled in your brain, and I'll even come around and like look at what you're doing and discuss with you. It's more like a practice quiz. And so there's no reading for next class. Just prepare for the quiz. All right, so 1.6 is applications of linear systems. So this is what we're going to talk about today. What you read about in your book gave 4 applications: economic sectors, chemical equations, network flow, and difference equations. So we might come back and do this little activity that I designed Tuesday, but for now I'm just going to do a brief demo of each of the kinds of questions. All right, so this first one is about economic sectors. All right, so it says there are 3 countries producing, consuming, and trading goods. Country A trades 5% of its goods to country B and another 5% to country C. Country A consumes the rest. Country B trades 10% to A and C, and they consume the remaining 80% themselves. C trades 20% to A, 10% to B. So what values must be attributed to each country's goods in order to reach equilibrium in the system? So equilibrium in the system means that everybody is producing just as much as they're consuming. So that's how we solve this system. We want to set each country's consumption equal to its production. Yes. Yep. Yep. All right, so set each country's consumption equal to production. All right, so let's look at country A. All right, so country A, 5% of its goods goes to B, 5% to C, which means how much does it consume? 90%. Okay, so 90% of the production for country A so 90% it consumes itself. 10% goes to country B, and 20% of the production goes to country C. So that is consumption. That's consumption of everything that A produces, right? So this is the production of country A. Production of country A equals consumption of all of that stuff. So the production of country B, take everything that B produces and let's see where it goes. So country B, it gives 10% to A and C. So we're going to do 10% is consumed by A, 10% is consumed by C, so 80% is consumed by itself. Okay, so think about country A, right? they produce some amount. That's the production of country A, right? And then percentages of that, so the consumption has to equal production in order for things to be in equilibrium. So country A produces some stuff. And then we say, okay, 90% of that stuff is kept by country A. Oh, did I do it wrong? Okay. And they give 5% to the other two. Where did I get those numbers? I give 5% to the other two. There we go. Did I do the next one right? Yeah. So country B produces some stuff. 10% of that production goes to country A. 80% goes to country B, and 10% goes to country C. All right, and then country C produces some stuff, and 5% of it goes to country A. 10% of it goes to country B, and 70% is consumed by country C. So now I basically have a system of 3 equations with 3 unknowns, the production of each country. What doesn't add up? Okay. Yeah, so country A consumes 20%. Typo in my solutions. There we go. Yep. Okay, now everything's good, right? Okay. So 3 equations, 3 unknowns, and we can solve it using the methods that we've learned so far in this class. So first, I would make all the right-hand side 0, so you get negative 0.1 production of country A plus 0.1 production of country B plus 0.2 production of country C equals 0. And then you could set up a matrix in RREF, right? Do that for the other 3. Make sense? Then solve. I'm not going to solve it. Think about the rest of it on your own. This is negative 0.1. I subtracted 1 PA from both sides so that all the variables were on one side, constants on the other. What? Okay. Negative 0.1, and this is 0.05. Got it now? No. 0.9 minus 1 is negative 0.1. Nope, because they're not like terms. You can't subtract, like, you're not subtracting from those. P sub A is the only variable. I think I did this totally wrong. Yep. All my original numbers were right, and I was just explaining it wrong. Okay. Sorry. All right, let's think about country A. what country A consumes has to equal what country A produces. Okay, so the production for country A will be P sub A. All right. Now let's think about what it consumes. Country A. It consumes stuff made by country B and made by country C. How much of their stuff does it consume, right? So let's see, country B gives 10% of its stuff to country A, right? So we take 10% of the stuff from country B. Country B's production, 10% of it goes to country A, consumed by country A. Okay. And then let's see, what about C? How much of C's production does A consume? So C trades 20% to country A. So country A takes 20% of country C's production. And then country A consumes how much of its own production? 90. So it has 0.9 of its own production. That's where the numbers come from. And then we do that for each country, right? So country B, its production has to equal its consumption. So how much of country A's stuff does B consume? 5%. So I have 0.05 of country A's stuff. How much of its own stuff does it consume? So country B gives 10% to both A and C, consuming the remaining 80. So I have 0.8 of its own stuff. And then how much of country C's stuff does it consume? 10. And then we do the same for country C. Okay. Its production we'll just call P sub C, and then we have to set that equal to its consumption. How much stuff does it use? So country A's stuff, it gets 5% of country A's production. And then how much of country B's production does C consume? 10. And how much of its own stuff? 70. Now you have 3 equations with 3 unknowns, and you know how to solve that now. So we're going to move on. That's how you set it up. And you have the solution on the back in case you missed anything I wrote down. Okay, question 2. We might have time to get through one more example. And then we'll do the other 2 at the start of next class. All right, 30% of Mexicans leaving Mexico for the US yearly, leaving 70% behind. 20% of Americans leaving the US for Mexico yearly, leaving 80% behind. The population of the US and Mexico in the year 2000 being 200,000 people and 100,000 people respectively. Obviously, these numbers are just completely made up. So this is not an accurate problem. What will the population of the US be in 2003? So we make something called a migration matrix. So when you have people or animals or whatever moving from one place to another and back, we create a migration matrix. Okay, so 30% leaving Mexico for the US. So all right, going from to. It's a 2x2 matrix, yep. So from Mexico to the US is 30%. From Mexico to Mexico, so staying in Mexico, 70%. From the US to Mexico is 20%, and from the US to the US, 80%. So this is what we call the migration matrix. when you multiply the migration matrix times the populations of Mexico and US, let's see what happens. So I have 0.7, oops, 0.7, 0.3, 0.2, 0.8, multiply by the vector 200,000, 100,000. So when you do this, if you take the row times column approach, where you picture the row turning and you take the dot product, right? 0.7 times 200,000 plus 0.2 of 100,000. So you're saying that's saying 70% of Mexico's 200,000 plus 20% of the United States 100,000 people. What is that going to come out to? What is that representing? Mexico's population, right? 70% of the people that were already there stay. 20% come from the United States, right? So this is Mexico, US, the result. And then when you do the 0.3, 0.8 times the current state vector, you get 0.3 times 200,000 plus 0.8 times 100,000. That's doing 30% of Mexico's current population moving to the US, plus 80% of the United States population staying. It gives you the new US population. So this is 2001, right? 1 year later. So that's going to come out to 160, 140. How would I get the population in 2002? The next year. Just use those numbers. Use the migration matrix again, right? So you just do 0.7, 0.3, 0.2, 0.8 times your 2001 numbers. And that's going to be some numbers, and it represents Mexico 2002, US 2002, and then to get 2003, you just do it one more time. And I'll let you finish that on your own, and we will do the next two kinds of problems on Tuesday.